Good afternoon. In this lesson, we're going to be taking you through the steps of how a skeleton develops from infancy, and we're even going to progress through the lecture here how it eventually causes bone loss in the elderly. We'll also be talking about how a bone repairs itself. Now, this slide is showing a developing fetus. This is fetal development. Now, bone develops, if you look at this carefully, these spots right here that I'm highlighting now, and down here by the fingers, the clear areas or light yellow areas are areas where bone is not yet formed. Bone is shown by the dark pink areas. So as you can tell here, the other areas that are not pink are cartilage, and all bone development begins with from a type of cartilage called hyaline cartilage. Now, if you look at this, commonly people say, "Hey, I've heard that children have more bone than adults." Well, look carefully. If you look at this very carefully over here, because bones aren't fused, yeah, children do have more bones than adults. Because remember, right down here on the pelvis region, remember there are 3 bones fused there to produce the pelvis, and those bones are not fused in this diagram. Now, there's 2 ways that bone can form. One is called intramembranous ossification. This occurs with the flat bones, like in the skull, where a membrane is developed and bone replaces the membrane. The other is endochondral ossification. This is common in the long bones, where the cartilage develops into bone. In either case, cartilage is going to be gradually replaced by bone, and generally it's going to be the hyaline cartilage. Now, in bone growth, there's 3 kinds of bone cells that you need to be aware of. The first of these are called osteoblasts. Osteoblasts are going to make the cartilage deposit calcium. They're basically the bone-forming cells. The second type of cells are called the osteocytes. These are the true bone cells, that you find within the bone. They're basically involved with the routine turnover of the bone. The end of your femur, for example, with all the pressure on there all the time from standing, those osteocytes are generally being recycled and replaced as the bone is worn away from all the daily stress. Now, the third type of bone cells are called osteoclasts. These are bone-destroying cells. In the case of remodeling bone, which we'll talk about later, osteoclasts remove bone, the hard bony matrix from other areas and return calcium into circulation. So these would be cells that are very important in maintaining your calcium balance. Now, one of the most important features in making bones grow longer are epiphyseal plates. Epiphyseal plates are also called the growth plates. If you look at these pictures over here, where I'm pointing right now, this is your ulna coming across here. And notice that the ulna actually has 2 parts and a space in between. Because cartilage is less dense than bone, it doesn't show up as anything right here, so you see an empty space. This would be the bone of a child or somebody who is not fully developed yet. Look at the same area on this picture. I'm highlighting the same area. Here the growth plate is closed. That means you've ended your growth. Now, all that happens here, to make it real simple, the new cartilage continues to be produced on top of the epiphyseal plate. As that happens, the bone gets longer and longer. And eventually, those cartilage that's been grown here is gradually replaced by bone. Now, here's the epiphyseal plate on the drawing, right here. Okay, here's your bone. Okay, as the shaft or diaphysis elongates and pushes more cartilage up here, bones get longer and longer. And eventually, right down in here, this epiphysis, the end, the cartilage gets replaced by bone. Now, when the growth ends, as in this picture right here, you see a line. That is called the epiphyseal line, when all the cartilage has been converted to bone. So when you look at a skeleton, if the epiphyseal line is present, then growth has stopped. That person has reached physical maturity. Throughout our entire lives, we'll always experience appositional growth. Appositional growth simply results in the increase in the diameter of the bone. So this is going to happen if you are especially doing physical labor. As you apply more stress to the bone in order to keep the bone from breaking, the body naturally increases the thickness of the bone. So your bones do get thicker. That's how we found many times in the fossilized remains of ancient humans. We kind of guessed what kind of work they did or what their status in the society was. You know, people that were very prominent in society had less of a diameter of the bone. The slaves, the workers of the society, generally had the thicker bones. Now, the appositional growth, just making it thicker, is also responsible for bone repair, which we'll talk about on the next slide. The way it works is pretty simple. Underneath the periosteum, which is the outer covering of the bone, osteoblasts just start depositing more bone. It's that simple. And the bone starts to gradually increase in thickness. But remember, if the bone increases too much in thickness, it becomes heavier. So to kind of counteract that to an extent, osteoclasts on the inside are actually going to start dissolving some of the bone. So bone is only deposited to the thickness it needs. As it gets too thick, it starts to become too heavy, osteoclasts are going to remove some of this bone and return the calcium into circulation. Always remember that bone is living tissue. You know, when people say, dry as a bone, as a phrase, that's pretty misleading. You know, bone is living tissue. It will repair itself. So that always leads to the question, is a tooth a bone? Well, the answer is no. Because if tooth were bone, then would we ever need to visit the dentist to repair a cavity? If your teeth were like the bones, they should repair themselves. Now, in bone repair, if you break a bone, one of the first things that happens, as you see in this first slide right here, the blood vessels in the periosteum on the outside here are ruptured, and the blood vessels that run through the bone are also damaged. So immediately you get a clot or a hematoma. Now, the hematoma, which you see right here, is developed into what we call granulation tissue. Granulation tissue there. The granulation tissue is a really thin, kind of a pink type tissue that starts allowing blood vessels to work their way on through. In any kind of tissue repair, you first of all have to have a blood flow in here to remove the damaged red blood cells or damaged cells of the tissue and bring in nutrients here to begin repair. So step one, we got to get something in here. We got to have some way to get the necessary materials in and the harmful materials out. Step two in bone repair is what they call soft callus formation. Eventually, we start getting a soft fibrous cartilage running through here. Now, the collagen fibers that run through here are going to start forming support, replacing the granulation tissue into something a little firmer. Okay, now as you see in the picture here, we're all starting to see that we're going to get some blood vessels to start running through here, repair themselves all the way through. Step three involves the osteoblasts. The osteoblasts will form what's called a hard callus. Very beginnings of bone around the outside, and that will form a small bump. So hence it's called a collar, a bony collar around the outside. This is going to help keep the bones in place while the rest of the repair work continues. Finally, if you looked on this last slide here, you had a bony callus, a big bump. Eventually, that bony callus, osteoclasts, are going to start removing that extra bone and returning the bone back to its normal shape. That's why 6 to 8 weeks, excuse me, 8 to 12 weeks after a broken bone, you're going to have the bone back to normal. It will take between 8 to 12 weeks. Some people get healed up a lot faster. I've known people that have had fractures repaired, and back to normal in 6 weeks, 4 to 6 weeks. But the elderly, it's going to take longer. All tissue repair, all bone repair is going to be dependent upon your diet and your general health. Now, I'm not going to test you on identifying all the different types of fractures you see on this sheet. I just put them up here so we could have a little discussion. Most people your age are probably more familiar with the green stick type fractures. Green stick fractures, like right here, get their name because if you took a branch of a tree that was still green, still growing, and you bent it until it finally snapped, it wouldn't snap completely in half like a dried piece of a dried stick would. They will just splinter. That's a green stick fracture. Fractures can be repaired with either closed reduction, which means that they will just manipulate the bones back into place without surgery, or open reduction, where they'll actually do surgery, install plates, and a good type of injury like that would be one like this. Open displaced fracture, which we commonly call a compound fracture. The doctors will have to surgically realign the bones and insert screws and pins and hold it all together. Now, there are a couple bone disorders that you need to be familiar with. Now, we all have spinal curves, and we've talked before in the other unit here about the value here. Spinal curves do prevent jarring of all up and down our bodies. But some of the problems that come from this curve disorders are scoliosis and lordosis. Scoliosis is a lateral curvature of the spine, like right here. If you look at where I pointed here, you see how the vertebrae go off to the side. That's scoliosis, and very common in rapidly growing young people. Lordosis, right here, lordosis is an abnormal curvature of the lower back where it arches forward. You see lordosis a lot in pregnant women, overweight men, and in the old days it used to be the old gymnasts that routinely did their back bends and everything with bending their lower back. Those gymnasts today are having some problems with their back problems. Something that we all may come to is osteoporosis. Osteoporosis, like you see in this picture right here, here's normal bone right here with the trabeculae and the spaces between them. Here's osteoporosis, where most of the bone has been lost. Now, osteoporosis, as the bone disintegrates, results in another kind of curve called kyphosis. This is also called widow's hump, where the top of the back hunches over, where the elderly women get a hump in their back. Now, osteoporosis has been directly tied to a lack of estrogen. So some forms of therapy for osteoporosis or prevention is estrogen replacement. Now in lab here, we're going to start looking at some of these examples in lab. So bring your questions tomorrow and we'll take a look at those. Thank you.